Okay, here we go. Um, this lesson is going to be over order of operations, and I'm hoping this one goes by fairly quick because most people have been doing order operations for a while now. So I'm really only going to throw like one or two things at you that maybe you haven't really seen before. And so this will be really mostly review. And so we're going to look at evaluating expressions, both numerical and algebraic, using order of operations. And then we're going to also look at something that I call defined operations. And you see problems like this on the ACT quite a bit. I could almost guarantee you that when you take the ACT, you'll see a problem of this sort. At least one, because they kind of like to trick people on the ACT. So the first thing we want to talk about with order of operations is grouping symbols. And grouping symbols in math are a signal to sort of do whatever's in the grouping symbols first. And I'm sure you remember parentheses and brackets, but the division bar can also be a grouping symbol, as can absolute value bars, as can the square root. In this lesson, we'll see parentheses. I don't remember if there were any brackets or not in the examples I used, and we'll also see a division bar a time or two. And of course, we'll see absolute value and square roots more later in the year, and I just want you to be aware that if there are things inside of them sort of all together, then they are also acting like a grouping symbol. And so, order of operations, we agree that operations should be done in this order. And this may not be sort of the way you're used to seeing this presented. Grouping symbols first, starting on the inside, working your way out if they're nested, if there's grouping symbols inside of grouping symbols. Then we do exponents and radicals, then multiplication and division, then addition and subtraction. I like to group them in this way in terms of the order of operations. So there's kind of two things on each line: grouping symbols, exponents, radicals, multiplication, division, addition, subtraction. I've also doubled these things up for reasons we'll get into more later in the year. But the basic idea is that you start at the top and you work your way down. You might be wondering, well, what if there's a multiplication and a division, or an addition and a subtraction, since a lot of problems tend to have multiple copies of both of those operations. Well, we're going to agree that if two operations have the same priority, you work it the way you read in English, left to right. And so if you have this problem with nothing but additions and subtractions, we're going to agree that you start on the left and just work your way to the right, which I did for you just to kind of give you a feel for that. So you do 3 plus 2 is 5, 5 minus 5 is 0, 0 plus 1 is 1, 1 minus 2 is negative 1. This way we kind of all agree to work problems the same way. Our answers should agree with each other. That is it. As you can see, only other thing we really need to do here are some examples. We're going to evaluate, and evaluate we may have talked about in class some, but I just want to remind you, stress here that we're finding a value. And so you look at this first little problem, there's no grouping symbols, but there is a multiplication and a division, and so we would need to do those first. They have the same priority, so we would do the one on the left first. 5 times 6 is 30. Division takes priority over subtraction, so 10 divided by 2 is 5. You hear the cat over there digging. Cat, you're becoming quite the guest star in this. 30 minus 5 in this series. You've not been in this one yet. 30 minus 5 is 25. So the final answer there is 25. We'll pause for a second because I'm sure that's distracting. Alright, and I'm back, and hopefully the cat is done. So we got this next problem. Still no grouping symbols, but this time I threw in a couple exponents. And with the exponents, you could also go left to right, or in most cases you can go ahead and evaluate each of the exponents at the same time. So we have 3 squared, so 3 times 3 is 9. So we would have negative 5 plus 9 minus 2 to the third, or 2 times 2 times 2 is 8. And so we would have -5 plus 9 is 4. 4 minus 8 gets us our grand total of -4. Alright, this problem I threw some parentheses in, but it was just to sort of group the negative with the 3. And so what we have in this problem is a subtraction, an understood multiplication right there between the 2 and the parentheses, and then a power. And so we would do the power or the exponent first. Well, a negative times a negative times a negative is still negative. 3 times 3 is 9. 9 times 3 is 27. So now we would need to do the multiplication. You need to do -2. Then 2 times -27 would be 54, because double 25 is 50, and so this would be double 25 is 50, and then 2 more doubled would be 4, so 54. Of course, this is now 3 plus 54. So the final total here is 57. And then this problem, it's not exactly everything, but now you're finally kind of looking a little more complicated maybe. We do have parentheses, an exponent right here, a multiplication right here that's understood, an addition right here, an addition right here, a subtraction in the parentheses. I can't remember now if I said that or not. And then this 2 happens to be a negative. Apologize, by the way, for the ding. So what we would need to do first here is inside the parentheses, 5 minus 7 is -2. And then we would need to follow the exponents next. So 8 squared is 64. 8 times 8. Now we need to do this multiplication next, and don't want to write my negative. 3 times -2 is -6. Okay, now we just go left to right to take care of these additions. -2 plus -6 is -8 plus 64. The grand total here is 56. I want to say something real quick before I move on. I forgot to set this up, so we'll set it up real quick with a new blank slide or blank canvas. Okay, so here we go. I want to talk a little bit about something that a lot of you do that I don't like very much. Is when I say order of operations, you just immediately look at me and say PEMDAS. And I say, no, not PEMDAS. PEMDAS isn't good enough for us. So if you insist on PEMDAS, if you're just a huge fan of PEMDAS and you can't let it go, then you need to at least start working on the following. PEMDAS is not good enough. This would be good enough. PEMDAS needs to get replaced in your mind with Zardoz. My good friend, Zardoz. And then the idea here is this is grouping symbols, exponents and radicals, multiplication and division, addition and subtraction. And so I'm basically taking the P and being a little more clear that it's not, the parentheses are not the only grouping symbol. And I'm taking the E and saying, well, we got to throw in radicals somewhere, and the natural place for radicals is with exponents. And then the rest is kind of what you're used to. So if you love PEMDAS, learn to start going to Zardoz. Okay. A little trickier, but same basic idea. We're going to start with some problems that now, instead of being numerical, they're algebraic. So there's some variables. And so our first step is to substitute in variables and make sure we're replacing the variable with the correct number. And so for y is going to be 3, so I'm going to use parentheses to emphasize the substitution, -2, or excuse me, -2. And then x, I'm going to substitute -2. We have a multiplication here, and a subtraction. So this would be 12 minus, I'm going to start cheating on order of operations a little bit. A lot of you would go ahead and do that multiplication as well. And so we would end up with 12 minus -4, but minus negative becomes plus. So I see a lot of students do that little move right there. 12 plus 4 is 16. Final answer. Over here we would have 5 plus, and then it's really, really super important that when you substitute a negative, you be really, really careful with those parentheses. 5 plus -2 squared minus y is 3. We got some parentheses here we don't have to have. I didn't really give myself enough space, but I'll try to make it work here. So the power, we would go first, -2 squared. Well, negative times a negative is positive. So this would be 5 plus 4 minus 3. 5 plus 4 is 9. 9 minus 3 is 6. Alright, 3 times x is -2 minus 7 plus y is 3. You could argue that this inner set of parentheses here and this set of parentheses here from the substitutions, you could argue those are optional. What's -2 minus 7? Well, if you owe me 2 and you owe me 7, you really owe me 9. And so we would have 3 times -9 plus 3. We do the multiplication first and get -27. But then add 3, not a very good 3, to get -24. Okay, understood multiplication here. X times y over 2. This is the fraction bar here is acting as a grouping symbol. So you would have to do this multiplication first. So this would be -2 times 3 over 2. Remember, there is an understood multiplication right here, just like there was there. -2 times 3 is -6. But when you divide that by -2, final answer is -3. Hopefully you were doing a ton of these in Algebra 1. So if you're paying lots and lots of attention, maybe you've noticed that the bottom looks a little strange. And so the bottom is an example of what I call a defined operation problem. And these are on the ACT all the time. Because what happens with these is somebody glances at the problem, they see that the operation symbol, where it should be a plus or a minus or a multiply or divide, is some just random symbol like a heart, or I used little clover looking leaves or diamonds, or the @ symbol is just some random symbol. And they're like, well, I never learned that one. My teacher must have forgot to show me how that symbol works. But what's really going on here is the idea that you've created a rule, or a rule has been created for you, and you have to follow this rule. Okay? And so the idea is that the x within the rule, okay, on the other side of the rule, it's going to show you what to do with x. And then the y within the rule with the clover, it's going to have to show you what to do with y. Okay? And so that's how we work it. So let's try one here. 5, and then you just read this, whatever makes sense to you. Leaf, clover, symbol, I don't care. Give it a name and be consistent. And so we would have 5 clover 3 would be 5 squared minus 3 all over 2. And I had some optional parentheses there I could have left off, but since we kind of talked about that on the last slide, I think we'll be alright. And so following order of operations, this will be 25 minus 3 over 2, which is 22 over 2. And so in the ACT, you would pick the option that this is equal to 11. For 3 clover negative 1, we would have 3 squared minus, and then parentheses negative 1, because when you substitute negatives, say hi cat, say bye cat, we'd have 2, so we have 3 squared minus negative 1 over 2. We got to be careful with our negatives. 3 squared is 9. Again, I'm kind of starting to cheat and do some of the order of operations stuff just out loud. Minus a negative becomes a plus. 9 plus 1 would make 10. 10 over 2. So if this were the problem, we'd say it's equal to 5. And hopefully you're seeing that even though it might have looked confusing at first, it's just a matter of identifying that, hey, this is x, this is y, I'm using this rule. This is x, this is y, I'm using this rule. This is x, this is y, I'm using this rule. So let's try this one. We would have negative 1 squared. Parentheses aren't optional there because you're substituting a negative. Minus 1 over 2. Negative 1 squared is positive 1. Minus 1 over 2. Well, hey, that's 2 over 2. Excuse me, that's 0 over 2. And so this one happens to equal 0. It simplifies to 0. Excuse me. Alright, so how do you think you work this one? How do you think you work this one? Well, even though it's a defined operation, you still have to try to follow order of operations. I'm going to actually leave this one for you all to play with, and then we'll see if we manage to get it right in class. But before I just leave you hanging, realize that you would need to do the 2 clover 3 first. Whatever number you get, take the opposite of, and then clover that number with 1. And so we'll kind of pause there, see if you can do this one on your own, because if you can do that one on your own, you really understand this idea. So that's going to be it for now. Thank you very much. I'm hoping to get all 3 of these done in a week, which we will have to see. Thanks for your time. See you in class.